Assalamu alaikum warahmatullahi wabarakatuh. This is Dr. Ali El-Moursy in Digital Logic Design classes, and we are in lecture number 26 for the design of synchronous sequential circuits. The design of synchronous sequential circuits is two parts. Part word problems, similar to the word problems of chapter number 4 for combinational. And this is the toughest part of the whole course, because to convert, to translate the word problem into a state diagram is not easy. This is a kind of exploratory process. You have to explore the state diagram. You don't have it. State diagram, as we mentioned, it's a group of circles for the states and a group of arrows for the state transitions. There is no guidance, clear guidance in the problem. How many states do you have in the problem? You may also to design the circuit with too many states, and the larger the number of states means the larger the number of flip-flops for the design, means larger design, means not optimized or efficient design. The larger the number of states means the larger of flip-flops or flippies and the larger circuit. So that's why there is a subject called the state reduction. We will not go into that. However, we will try our best from the beginning to build the state diagram with the minimum number of states, or with the appropriate, convenient, efficient number of states. And this should be done in an exploratory fashion. Okay? Now, once you build successfully the state diagram, the steps coming after that are piece of cake. It's easy, because once you have state diagram, you can convert the state diagram into state table, from the state table to state equations, and then draw the circuits. The steps after developing the state diagram is quite easy, is simple, is pretty straightforward, is automatic. Okay? So we will cover them for the different number of flip-flops that we have. However, we wanted to start with the toughest step, which is developing the state diagram. In this lecture, we will, part 1 for lecture number 26, we will develop a state diagram for an example. As we will see here, we will read this example, we will build the state diagram, and in the next part of this lecture, we will really design the circuit, converting the state diagram into circuits through going into the steps that we have just mentioned: state table and state equation, then the circuit. Okay? Then in the next lecture, lecture number 27, we will explore different examples for how can I build the state diagrams. We will take at least 3 examples. This is the first one, and we will take maybe 3 or 4 other examples. Okay? So we will demonstrate one example in full. Okay, starting from developing the state diagram till the end. However, in the next lecture for 27, we will just do the building of the state diagram. The steps after the state diagram in the next lecture, or for the other examples, will be left for you as a homework, as an examples that you can train yourself on them. So let's get started with our example here. Okay. The problem is telling me to, or asking me to design a serial 2's complementer. So I have first to understand what's the 2's complementer. However, right now, since the word serial comes into the question, this indicates that It is a synchronous sequential circuit or sequential circuit in general, because the process is done, you will be performed serially. The circuit for what? For a 2's complementer. What's the 2's complementer? 2's complementer is a circuit that generates the 2's complement of a stream of bits, okay, for some set of bits, generating their 2's complement. If you still remember, we learned how to get the 2's complement using two different techniques in chapter number 1. In chapter number 1, we have the conventional way, which is actually getting the 1's complement of the number and then adding 1 to it. We don't want this method. This needs an adder circuit, okay? And to perform this, I have to know the bits beforehand. I have to know the number of bits for the input and to generate the output. However, the circuits requested here is different. This is serial 2's complementer. That means it is converting the bits of the input and generating the output on fly while they are coming. So the advantage of this circuit, I don't need to know the number of bits for the inputs. And this is explicitly, okay, mentioned here. If you read the text of the problem, you will not find that the number of bits for the inputs is mentioned anywhere. يبقى design a serial 2's complementer with one stream of inputs X. So X is the name for the stream of inputs, bits. How many of them? We don't know. We have none of this information. We don't have this information. And it could be anything. It could be 100 bits. Okay? So a stream of bits of inputs and one stream of output Y, where Y should be the complement of X. As we mentioned, we learned two methods for 2's complement in chapter number 1. One is the 1's complement plus 1, and this needs knowing the number of bits. But I can build the serial 2's complementer using the concept of the other method of 2's complement. Okay, if you still remember that the second method for the 2's complement is keep the ones as they are with the first one, keep it as it is, and flip the next bits. This is the method that we will use in order to build this circuit. First of all, the first thing that we need to build here, just to demonstrate, to show you what's this circuit, we want to build a block diagram for the problem. And the block diagram is very simple. It's a circuit called serial 2's complementer. It has X as a stream of input and Y as a stream of output. So what I have drawn here is simply the block diagram for the problem. However, in order to really solve the problem, I want to demonstrate or build the state diagram for that problem. Before I go and build the state diagram, I need an example. I want to see how this circuit should behave. Okay, so I simply here will just show the following demonstration. Here we have I want to show how this circuit would work. So I will just pick a random example for the bits of X, and I want to show the corresponding bits of Y. Okay, so I will just pick any random sequence of X. Okay, assuming that X has 0, 0, then 1, followed by a 1, followed by a 1, followed by a 0, followed by a 1, then 0, then 0, then 1, 1, then 0, 1, 0. As you can see here, I wanted to mix the different number of bits, then 1 followed by a 0, 2 zeros followed by 2 ones, then 1 followed by 2 zeros. Any mix of bits to train my circuit. By the way, the X here could go forever. I don't have a specific number of bits for X. This is just an example. Now, how this circuit should work, this circuit should generate for me the 2's complement of X. Okay, so actually, I wanted to start in a train my circuit. Okay, by the way, I know beforehand the value of Y. Yes, we know the value of Y. I can actually list the Y here. Would be Y. In the method that we learned for the 2's complement, I have to keep the zeros as they are until I face the first one. The first one will be as it is, and after that I should flip the bits 0 to be 1, L1 should be 0. So this is supposed to be the output of my circuits. Everybody agree? This is from our knowledge from chapter number 1. Now I want to see how can a state diagram actually represent this, or describe this, or generate this. State diagram means the circuit, when I give it the order to start, the circuit should be in some state. By the way, I don't know the number of states yet. I will explore them. So I assume that initially the circuit in one state called this state, I will give it a name. I will call it S0. Before I go and explore the problem, I have to do a very critical decision. We talked in the last lecture about 2 types of synchronous sequential circuits. We have a circuit called, or the circuit could be, if the circuit has an external output, that means the circuit could be one of 2 things. It could be either a Mealy circuit or a Moursy circuit. For developing the state diagram, I have to do my decision from now, before I start working. And for this example, I will design the circuit using Moursy state diagram. So I assume that the circuit is Moursy. What does it mean by circuit is Moursy? Means that the output of the circuit Y should be attached to the states. It should be inside the states. If I have here S0, I have the state S0, and Y is attached to it. So that means I have to define some value for Y. So now this is my initial state. So I will here reflect on the present state, and I will show here the next state. And I will use an exploratory methodology. I want to explore the states diagram. Okay, agree? Makes sense? Now, what is my initial state? I'm definitely initially in state S0. Now, I have to define some value for the output since I'm building Moursy. So what's the value of output? Assuming that the output initially will have the value 0. So initially Y equals to 0. Now, I start receiving the input. How many inputs do I have for the external input of the circuit? The circuit has only one external input called X. So I expect to see two transitions from this state, when X equals to 0 and when X equal to 1. This is what we agree on. Right. Where those transitions will send me, I'm still exploring. So my goal is not to create states needlessly, because as we agree, more states mean bigger circuits. So accordingly, I want to try my best to be conservative in the number of states that I'm creating. As much as I can, as long as the circuit works fine, I want to either stay in the states or as much as I can, or stay in the states that is created, or if I cannot, I will create more states. But if not, I will stay in the states. Agree? Deal? So let's go and explore. Now I am in state S0. Y is 0. And I start receiving my first inputs, lower X equals to 0, as the sequence here shows. Okay? Again, this, I just put it arbitrary. It's just an example to train the state diagram. As we mentioned, we want to be reserved as much as we can. We need to, as much as we can, not to creating new states. We want to stay in our state as much as we can. So if X equals to 0, as long as I can stay in, let me stay in the state. So I will assume that I can stay in my state. Okay? This state defines Y equals to 0. So is this the expected output? Yes, it is the expected output. Based on the 2's complementer, if X equals to 0, Y will stay 0. So that means I will assume, or it seems there is no problem for me to just stay in the next state to be also S0. That means in the next input, I'm starting while I am in S0. I received another 0. So this state diagram indicates to me you are staying in the state producing Y equals to 0, which is perfectly correct. So I will stay in S0 and will produce the output 0. Agree? Now, let's go and explore the next step. I am in S0 and I start receiving X equals to 1. Our definition, our goal is not to create more states. But do you think that I can stay in the state? If I assume that I'm staying in that state, this state defines Y equals to 0. However, for this complement, I have to switch the output from 0 to 1, which actually is broken here. This is not valid anymore here. So that means when I receive X equals to 1, I am forced to get out of this state, to create new state for the healthy output to be produced. So that means if I am in S0, I start receiving X equals to 1, I cannot stay in S0 anymore. That means my next state should be a new state. I will call this simply S1. Y is defined also for S1. What would be the value of Y? Definitely, I created this to change Y to 1. So Y for S1 should be 1. So that means I now have I am in S1, I produce the correct output. Now I'm in which state? I am now in S1. I have two arrows to explore for this new state. When X is 0 and when X is 1. Okay? Now S1, X1. Where should I go? I have three options. Either stay in S1 or go back to S0 or create new state. Can I stay in S1? The answer is no, because the output for the 2's complement should be switched to 0. While I define that for S1, Ly equals to 1, so I cannot stay in my state. So I have two valid options. Either going back to S0 through Ly equals to 0, okay, or create new state. So let's assume I will go to S0. So S1 and 1, I will go to, this is x equals to 1, I will go to S0. If I'm going to S0, will everything will be valid, will work fine? Let's see. I went to S0, that means I am now in S0, x is 1, so do I have an arrow for x1? Yes. If I am in S0 and x is 1, is this actually make me jump to S1 and the output will be 1. While right now I'm expecting y to be 0. So this means this assumption of going back to S0 is not valid, because actually starting after the first one, as you know from the definition of the shortcut of 2's complement, after the first one, I want always to flipping the value of x. Y will not be equal to x. Y will be equal to x complement. In S0, when x is 0, Ly is 0. When x1, Ly 1. So actually S0 will not help me, because afterward I want to start flipping the value of x, or the value of y based on x. Accordingly, neither the assumption to stay in S1 is valid, nor the assumption to go back to S0 is valid. So that means I am forced to create a new state. I will call it the state S. I will call it the state S2. In S2, when x equals to 1, I will jump to a new state called S2, okay? And the output for this state should be equals to y equals to 0. Agree? Since I have new state, that means I have new output that I can define. Y is 0 in two cases, in S0 and in S2 plus 1. Now, let me continue. Now I am in S2, okay? I am in S2 and I am receiving x equals to 1, okay? So, now I am here in S2, I received x equals to 1. That means I need a new arrow. Where arrow will send me? Now I have 4 options. Either going back to S0, which is not valid anymore, because in S0 x, y, and are matched. This is one thing. Or I can go back to S1. Can I go back to S1? No, I cannot go back to S1, because actually I need an output to be 0. Or I can stay in S2, okay? So is this valid? Yes, as long as I can live without creating new state, let me do that. So the correct option here, since I am in S2, okay, and I need the output to be 0, and so when x equals to 1, I will stay. So when x equals to 1, I will stay in S2 and Y will be 0. And if this even repeated maybe 100 times, as long as I'm receiving x1, I will stay in S2, which is y0. x1, y0, x1, y0, x1, y0. Okay? So I will stay in S2. Okay? And I will produce the output, the correct output, اللي هو equals to 0. Now I am in S2. I have a second arrow, اللي هو مين؟ x equals to 0. Agree? So this means new arrow. Where to go? Back to S0? No. Staying in S2, I cannot, because the output that I need now for the arrow for x equals to 0, I need y to be equal to 1. So I have two options. Either go back to S1 or create new state. Do you want to create new state? New state means extra hardware. So let's try to go back to S1. Is this valid? Yes, because y will be 1 and it didn't seem that I have problems. So I go back to S1. So now I am in S1. I am in S1. I received another 1. So 1 is already defined. I will go back to S2. And in S2, okay, and the output will be 0. Perfect, working perfect. Now, I am in S2. And I received 0. I will go back to S1. And I get Ly equals to 1. I am back in S1. Now I am S1 and x is 0. This is a new arrow. Not shown here. Right. S1 where x equals to 0. What is the output? The output is 1. So in this state, the output is 1. So I cannot go here. I cannot go here. I either stay here or create new state. There is no need for creating new state. So when x equals to 0, I will stay in the S1 and I will generate y become y equals to 1. Here I will stay in S1 and generating the correct y. Again, S1, 1, go to S2 and generating y0. S2, 1, staying in S2 and generating 0. S2, 0, go back to S1 and generating 1. S1, go back to S2. S2, 0, go back to S1. So I keep ping-ponging, flipping between S1, okay? This is the state where x is there, where x0, y is 1. There is the state where x1, y is 0, and those two arrows is switching me between the two states. This state diagram will work for any sequence of x to generate the correct y. If you don't believe me, go and try. Remove this sequence and try any other sequence for x and y. Will this work or not? Let me show you. Okay, let us assume or give a new sequence, a short one. I will not repeat for all of this. Just for demonstration. Okay, x, y, assuming that x, here x was starting by 0. So what if I starting x with 1 from the beginning? 1, 1, 0, 1, 0. Okay, now I'm exercising the state diagram. I'm initially in S0. Okay, now I am in S0. Okay, and the x is 0 or 1. X is 1. X is 1. The state diagram will jump me to S1 and y هتبقى 1. Correct? So let's drive this. So this is, what's the 2's complement of this? 1 as it is, then 0, 1, 0, 1. This is what should be generated. Is this correct? Yes. I am in S0, X1, that means Y1, and I'm now in S1. I am in S1 and X1, I will jump to S2 والواي طلع بكام؟ Y is 0, correct. I am in S2 X0, I will go back to S1 and I will have the output Y1. S1 1, I will go back to S2, we will get the Y0. So if you exercise this state diagram for any sequence of XY, you will find that the state diagram here is generating for you the correct value for the output and the transition correctly to the correct state. That means this state diagram is representing the state diagram or solving the problem, but for the 2's series, 2's complementary. Okay, this is part number 1 for this lecture. We will take a little bit of break and we will come after the break to see how can I convert this state diagram into a circuit. What are the steps that we will be following? Okay, see you shortly with the continuation of solving this problem. Thank you and see you shortly.